right, so this set of notes is on function transformations. In this section, we want to examine how the graph of a function can be transformed either by shifting, which the mathematical term for that is translating, stretching or compressing, or reflecting. So here we have three graphs. It says the following functions have been graphed at the right. So first off, we have the parent absolute value function, f of x equals the absolute value of x. That's graphed in black. And then we have two other functions that have been shifted. If you look, the green function is moved up 3 from the parent function, and the blue function is moved down 4 from the parent. So that plus 3 on the end and that minus 4 on the end is moving it up 3 and down 4. If you look at these little equations up here, it can be written, because this is the absolute value function, the absolute value plus 3 more. Notice the 3 is on the outside of the function for this vertical shift. Or you can write the function is shifted up 3. So the function plus 3. All right, so it says if we let f of x equal the absolute value of x, then each of the other graphs are formed by y equals the function plus k. K is that vertical shift. Explain the effect that changing k has on the graph of y equals f of x plus k. So once again, it is a vertical translation or vertical shift. That's what k is doing. And if k is positive, then the graph is moving up. And if k is negative, then the graph is moving down. Okay. Once again, you can say translation or shift. Doesn't matter to me. Okay, moving on to the next one. So here we have some parabolas. The parent function is f of x equals x squared. And then we have two functions with some translations. The first one, the green one, is x plus 3 quantity squared, and the blue one is x minus 2 quantity squared. If you look at the green graph is moved left 3. So that x plus 3 inside the parent is providing a horizontal shift left 3. The x minus 2 quantity squared, the minus 2 inside the parent, right, versus outside the parent. Outside the parent would be like this, right, is once again providing a horizontal shift, this time right 2. So if you look here, that's what happened, okay? For that, let's look at this one right here. This function being moved right 2, it can look like the actual function, x minus 2 quantity squared. Or notice this is inside the parent. We have an x minus 2. That means it's moving right 2. Okay, let's go ahead and summarize that here. In this writing, it says if we let f of x equal, that's wrong. This one is x squared. So let's put or f of x equals x squared, because that one's x squared, but it works for the absolute value function too. Then each of the other graphs of the form y equals f of x plus h, form y equals f of x plus h. I'm not a big fan of it saying f of x plus h. I feel like minus h is what I'm used to seeing, but I'm going to leave it the way it is and just adapt, okay, adapt to that writing. So this is going to be a horizontal translation or horizontal shift. I'll write that underneath here. Okay. And how I'm going to work with this is that in here, if you see an x plus h, that is moving your graph left a certain amount of units. And if you see x minus h, that's moving your graph to the right units. Okay, ooh, and I almost forgot to say, when you're writing equation or when you're translating this into x values, like if you see, no, I can worry about that later. Never mind. Skip that. Okay, so here it says the following functions have been graphed at the right. Oh, you know what I can say up here is that sometimes we'll be writing these as vectors, And when we're writing this as a vector with saying that it moves up and down k units, the x value would stay the same, and then the y value would move either up or minus k, plus or minus k. All right, so it'd be either, you'd either add that value or subtract that value from your y value. Same idea here, but with your x's, you're going to be, if it's moving right, you're going to add that because it's going to have to move to the right, your h value. And no, let's look like this, like that. And then your y value would stay the same. Oops, let me put my vector there. And then, or you would do x minus h, your y value. This is moving it to the right, this is moving it to the left. So like that's why I don't like this x plus h here, because that's kind of, we'll get to it. We'll cross that bridge when we get to it. Okay, so here we have some parabolas. Again, f of x equals x squared. And then notice that the parent in black there, we have a green function which is narrower, and then we have a blue function which is wider. So if you look here, what's changing on the graph is that we have a multiplier outside in front of the parent. And if you might saying like, how do you know it's outside the parent? That's because the parent is x squared right here. And if it was inside, it would look like this. That's inside the parent, right? And it doesn't look like that. If there's no parentheses, that means it's only around x, right? So we have a multiplier outside the parent. Outside is always vertical, okay? So this is a vertical effect, so I can start by writing that down. And then if you look at what the 3 does compared to the 1/4, the 3 is making the graph look narrower, right? But we don't just say narrower, we say what's happening vertically. It's being vertically stretched. It's like if you were to pull on the top of that from 0, 0, and it's getting narrower because of it. So this is a vertical stretch, S-T-R-E-T-C-H. I have to spell it to myself, sorry. And then that 1/4 is making it wider, which is a vertical compression. So this is a vertical compression, okay? So we have vertical stretch versus vertical compression. And then how do we tell the difference between these two? I should probably put vertical in front of this also. So I'm gonna do copy, paste. There we go, okay. A vertical stretch is you look at that, what's called the A value. The A value is that multiplier in front. You're gonna look at that A value. You're gonna disregard the positive or negative, so we're just gonna look at the absolute value of that. If that value is greater than 1, like 3 on that one right there, or 17, but even if it was -3, it's a vertical stretch. If that value is less than 1, I like to look at it as in between 0 and 1, right? The absolute value is in between 0 and 1, then it is a vertical compression, okay? And also A is a multiplier of Y, so when you're doing vector form, you would leave X alone because this has nothing to do with the horizontal, and then you would multiply a Y times that A value. All right, moving on to the next one right here, we have absolute values function. If you look at what's happening here, there's a multiplier, but it's inside the parent. If it's inside the parent, it's a horizontal effect. Okay, so if you look at what's the green one, what's happening to it, it looks like it got narrower, right? So if I want to describe what's happening to it horizontal, it's like someone pushed the sides in, right? From that black one there, pushed the sides in. Pushing the sides in is compressing it. So a horizontal compression, and then we also have a horizontal stretch. And this is your horizontal compression. And this is your horizontal stretch. Okay. And how do we know with those numbers then, just looking at the numbers, how which one's which? This is actually the opposite of what we had here. If A was greater than 1, it was a stretch. Here, if A is greater than 1, it's a compression. And once again, absolute value, the negative does not have to do with the stretching and compressing. If A is less than 1, absolute value that is, then it's a stretch. One thing I should say is that this is for this particular function, and then this is for any function. So notice that's inside the parent. A 2 would be So it's horizontal, and then a 2 would make it a compression. This right here, let's go back up to this one because I didn't talk about this one. This right here is for this particular graph, and then this is for any function. So this would be a multiplier of 1/4 outside the parent. So this is vertical, since it's outside, a 1/4 is a compression. Okay, so for vector form for horizontal stretches and compression, you're gonna change that x value, and what you're gonna do is you're gonna divide by the b value, comma y. Oops. I always wanna do a parentheses instead of a vector. Okay, then last thing that we have are our reflections. So if you look at these two right here, you have a negative outside the function, right? A negative outside the function. A negative outside the function is going to vertically reflect it. So this was the absolute value function, and then it vertically reflected. This was the square root function, and then it vertically reflected it, okay? And a vertical reflection, another name for that is a reflection over the x-axis or about the x-axis. So we're gonna say vertical reflection, or in other words, reflection about the x-axis. Okay. So what would you do for this, for a vertical reflection for vector form? X stays the same, and you would take the opposite of the y value for a vertical reflection, right? And one more left, and that is a horizontal reflection. So if you look right here, this was a square root function, and then it got reflected horizontally. And if you look at what has happened to the equation here, there is a negative involved as a coefficient in front of x, and it's inside. Remember, inside is horizontal, outside is vertical. So this isn't right. Ooh, there's a typo right there. Cross that out. This would be f of negative x, like that. Okay. Okay. Oh, and look, it's fixed right here, see? So if we let f of x equal, that's the square root function, then each of the other graphs are in the form f of negative x, y equals f of x. Explain the effect. This is a horizontal reflection, or a reflection about the y-axis. And how would that change in vector form? It would be negative. You would take the opposite of the x value, comma, the y value. Okay. All right, so that is the different things can happen. Those are the different transformations that can happen to our graph. And then now we just have it all summarized right here. And then there is a certain order that you have to do them in. Because if you do them in the wrong order, it might not give you those transformations. All right, so one thing, it says let's generalize. One thing, I have all the variables here. I have h, k, a, and b, and then it's f of x. That's what this is right here, f of x, okay? And then what these do to it. So first thing you need to know is that b actually needs to be factored out. So I hate that the way that this is written. So I'm gonna go ahead and cross this off because I despise it. It's not how it looks in my other set of notes, so I'll fix it before you even see it. And we're gonna do y equals plus or minus a, which is fine, and then times f of, and then b has to be factored out of your x value and your h value in order to get your horizontal shift correct. Okay, so b must be factored out, and I will fix the PDF version of, so it says that. Okay, so as a reminder, okay, what each of these stand for. Let's do it the way that it has here. So A is this value right here, okay? It's outside the function. These are inside, right? This is inside, this is inside, these are outside, okay? So outside the function would be vertical. And that multiplier there is either a stretch or compression based on if it's greater than 1 or less than 1. Absolute value, that is, stretch, compression. Okay, The b value inside the function, this is inside the function, right? That is a horizontal stretch or compression. It would also, if it was negative, be a reflection too. So same thing for A. It counts, that's where you look for your reflection also. The K value is outside the function. Outside the function is vertical, and that's a shift or translation. Oh my God, can't spell. Vertical, shift or translation. And then H inside the function right here, that is a horizontal shift or compression. Okay, now the order is important, okay, on which you do these. So the first variable that you're going to have to look at is H. So that is the horizontal shift, left or right. And then B, as a reminder, is the horizontal stretch or compression. And then also if there's a reflection, a horizontal reflection. Then A, which is the vertical stretch or compression, along with a vertical reflection if that's in there. And then lastly, K. And K is your vertical shift up or down, and you would have to look at that. So I have it memorized as H-back. I know it's not that great of a thing to remember, but that's how H-back. H-back is the order that you do it in. Okay, so on this section right here, it says describe the transformations that have been applied to the given function. Describe means in words, you have to do that, and you have to do it in the order that they're applied. So you do have to do it in the H-back order. Okay, so if you look here, there are two transformations that are happening. There are this and this, okay? So we will start inside the function because H is inside, right? So we're gonna start with H. H is your horizontal shift, left or right. This right here is moved to the left. So our first one is going to be a horizontal transformation or a horizontal shift, left 7. Horizontal translation, left 7. The other one that you have here, we only have one left, so I'm not going to be like, do we have any B values? What about A? What about K? So there's only one thing left, and there's this negative outside the function, so that's vertical. Vertical. And a negative in front is going to be a reflection, a vertical reflection. Yes. Now you could also say reflection over the x-axis. All right. Next one, we have two transformations happening. We have that 10 and that 20, or minus 10 and minus 20, or 10 and minus 20, however you want to look at it. Those two, okay? So we got to do them in the correct order. So we're going to start with H. There is a horizontal shift. It is right 10. So I'm going to say horizontal shift or translation, right 10. And then there's only one more, so I'm not going to say, okay, what's next, what's next? Obviously, you have to do that minus 20. That is a vertical shift or translation, down 20. All right, next one, we have two happening also. So we're going to start with H, which is horizontal translations. I look inside the function to see if it's moving left to right. It's not, so next. After H is B. B is inside the function also. There's nothing happening inside the function. So I'm going to move on to A. A is your multiplier in front. That's the first one we're going to have to do. So outside the function is vertical. So we're going to say vertical. And then I need to know if this is a stretch or a compression. A 4 is going to be a stretch. And then you're also going to say what the multiplier is, okay? So you're going to say vertical stretch with a factor, by a factor. You can say with or by a factor of. And then remember, for your Y value, you keep that Y value. So it's just by a factor of 4, all right? You multiply it by A, so 4. If it was vertical, we would divide by that. So it'd be X divided by 4, or a fourth. 2. There's only one thing left. It's that plus 17. So we're going to do a vertical shift up 17. All right, last one. This one is slightly different because if you look at the ones that we were doing, we didn't have any b-values to use in this. This one has a b-value, and the b-value must always be factored out so you get your horizontal shift right. So let's go ahead and factor out that b-value. We have y equals 1/3 times f of, we're going to factor the 2 out of both of these terms. So factoring a 2 out of a 2x is x. Factoring a 2 out of a plus 5 is 5/2. Remember, factoring out is the same thing as dividing out. If it was a 6, I would do 6 divided by 2. 5 is just not divisible by 2. And then minus 1. All right, so we have 1, 2, 3, 4 transformations here. So let's go ahead and do them in the proper order. We'll start with h. There is an h value. H is right here. This is being moved left 5/2. So I'm going to say a horizontal shift left 5. Halves, not 5. Horizontal shift left 5/2, or 2.5 is fine. Okay. All right, next one. So I did H, now I'm on to B. There is a B value of 2 that is inside the function, so it's horizontal. And remember, it's the opposite of what the vertical one was. That is a vertical stretch. This gave me a vertical stretch, so this is going to give me a horizontal compression. By a, I'm going to get my English right here, by a factor of, and then it's x divided by b, so you would take it and divide by that b value instead of multiply by that b value, so it's of 1/2. It's another way of looking at it is it's the reciprocal of 2. All right, and then for the third one, so I did HB, now we're on to A. The A value is 1/3. So we have a vertical compression. By a factor of 1/3. Now you might be saying, why isn't it 3? We do that for horizontal compression and stretches. For vertical compression and stretches, that is the factor. Okay, and then lastly, we have the vertical shift down 1. All right, so last we have these graphs here. We're gonna put it all together with some graphs. We're actually gonna do this one together and then you can pause the video. Actually, we'll do them all together just to make sure because they're all a little different. But if you'd like to try them on your own, you can, right? It says consider these functions y equals f of x. If you look, they're kind of funky. It's like 2 lines and semicircle-ish looking or semi-elliptical looking. So it says whose graph is below. Apply the given transformations to the function at the right. Use a different color for each graph. Be sure to write the rule and complete the table, then compare your results with other students. All right, so I don't know why we have to use a different color because that just seems weird. So, but we will do what it says to do here. So these are our x values, or our x comma y values, and then we are going to do f of x plus 2 minus 5 here for our, our new set of ordered pairs. That's the transformation that we're gonna apply to it, okay? So if you look at what this wants us to do, remember we have to do it in the correct order. So we have H, B, A, K. So let's talk about H first, because let's talk about our X values. To our X values, we'll be moving them left 2, okay? And I like to write my rule first instead of like doing the points first. It makes like my vector form. So for my X values, I'm moving them left 2. So I'm gonna subtract 2 from my X values. And then for my Y values, they're moving down 5. So I'm gonna subtract 5 from my Y values. Just makes more sense to me to write the vector, okay? So I'm gonna do that to all of my ordered pairs. I'm gonna subtract 2 from 9, which is -11. I'm gonna subtract 5 from 0, which is -5. I'm gonna subtract 2 from -6, which is -8. I'm gonna subtract 5 from -2, which is -7, so on and so forth. So I have -2, -5, 1, -1. And the last one is 4. Right, subtract 2, subtract 5, 4, -5. And now you can graph the new function. All right, so the first one's negative 11, which doesn't even fit on this graph paper. Whatever. 1, 2, 3, 4, 5, 6, 7. This only goes up to negative 8. So we'll go negative 9. It's extended here. Negative 9, negative 10, negative 11. Okay. Negative 11, negative 5. 1, 2, 3, 4, 5. So we're going to say right there. Hopefully this isn't an issue in the future. All right, the next one's negative 8, negative 7. So that's right here. Then we have negative 2, negative 5. 3, 4, 5. 1, negative 1. And 4, negative 5. 4, negative 1, 2, 3, 4, 5. All right, so we have straight line here, and then curvy one there. There you go. Beautiful. Okay, so if you look, it is moved left 2, down 5. Right, if you look from the original. Yes, beautiful. Okay, next, same function. We are going to move it left 1. So I'm going to take 1 off my x values. So here's my vector. I'm going to subtract 1 from my x values, subtract 3 from my y values. So this is f of x plus 1 minus 3. All right, subtract 1 from your x value, negative 10. Subtract 3 from your y value. Subtract 1 from your x value, negative 7. Subtract 1 from your y value, or subtract 3 from your y value, negative 5. 1 from your x value, 3 from your y value. 1 from your x value, 3 from your y value. 1 from your x value, 3 from your y value. And there are your points for this one. All right, now I'm going to graph these points, and it should be moved left 1, down 3. Otherwise, I did it wrong. All right, negative 10, once again, great. So I'm going to extend this. Here's negative 9, here's negative 10. Negative 10, negative 3, right there. Negative 7, negative 5, 3, 4, 5. Okay. All right, negative 1, negative 3. Negative 1, negative 3. Okay, so far I have that. And then we have 2, 1, right 2, up 1. And right 2, up. Oh, I did right 2, up 2. It felt weird. Right 2, up 1. And then 5, negative 3. 1, 2, 3, 4, 5, 1, 2, 3. We got this semicircle. All right, once again, gorgeous. Okay, here's the next one. All right, so this one is negative 2 times f of x minus 3. Good. Okay, so I'm going to write my vector rule here. So it is moved right 3, right 3. So x plus 3. And then the y value is multiplied by negative 2. So I'm going to do negative 2y. Right? Nice. X plus 3, negative 2y. All right, so let's go ahead and do that. We're going to add 3 to that, negative 6, multiply that by negative 2, still 0. Add 3 to that, negative 3, multiply by negative 2, that's 4. Add 3 to that, negative 3, still 0. Add 3 to that, which is 6. Multiply by negative 2 is negative 8. Add 3 to that, which is 9. Multiply 0. Okay, so 9, 0, 6, negative 8, negative 3, 0. I did minus 3. I should add 3, not subtract 3. Add 3 to that. Yeah. Okay, that looks good. And now I'm going to graph this. So this is going to reflect, right? Because it's got a vertical reflection. There's going to be a vertical stretch to it. And it is also going to be moved to the left 3. So be prepared for all of those. So we have negative 6, 0, 3, 4, 5, 6, right there. Negative 3, 4, left 3, up 1, 2, 3, 4. Okay. Negative 3, 3, 0, right there. Feeling weird, but it's okay. These are my straight lines here. Straight line. That's what I did first, right? 6, negative 8. 6, negative 8 is right there. And 9, 0, which is just right off the graph. feels, oh, because that's 7, -8. I'm like, it feels a little crooked. 6, -8 is here. There we go. So there is that stretch to it that's, I'm feeling. Okay. Last one? Yes, last one. Okay. All right, so we're doing f of 3/2 x inside the function plus 2. Okay, so I'm going to put down my vector here. So for my x value inside here, I have a 3/2 for my b value. So remember, it's x divided by your b value. So I have x divided by 3/2, which we don't divide by fractions. We multiply by the reciprocal. So that's the same thing as multiplying by 2/3. And then I'm going to add 2 to my y values, y plus 2. All right. So for my x value, I'm going to multiply it by 2 and divide it by 3. -9 times 2 is -18. Divided by 3 is -6. And then add 2 to 0. Multiply by 2 is -12. Divided by 3 is -4. Add 2 is 0. Multiply by 2 is 0. Divide by 3 is still 0. Add 2 is 2. Multiply by 2 is 6. Divide by 3 is 2. Add 2 is 6. 6 times 2 is 12. Divided by 3 is 4. Add 2 is 2. Okay, so now we can go ahead and graph these points. So a 3/2 is going to give us a horizontal compression. So it should be narrower looking, and then it'll be moved up to -6, 1, 2, 3, 4, 5, 6, up to right there. Gorgeous. -4, 0. Nope, right there. That's 0, 2. There's that piece. There's that. Okay, and then I have, don't get lost, 2, 6 right here, and 4, 2 right there. Looks good. Oh, look at that, it's beautiful. Okay. All right, that's it for today's notes. If you have questions, let me know.